Indonesia, the crossroads of two mighty oceans, where the waters of the Indian and the Pacific converge. Powerful currents help feed the most vibrant coral reef system on Earth. An explosion of plankton draws giants from the depths of the ocean.
It's just incredible when you see a manta ray sort of come out of the gloom. They're just magnificent, beautiful creatures.
A team of researchers has set out to study and save these gentle giants with secret lives. The giant manta ray, the largest ray on the planet, nearly as wide as a tennis court, as heavy as a car. One of the world's largest fish, fueled by some of the ocean's smallest creatures. Plankton. The tiny plants and animals that drift through ocean currents. The giant manta ray is one of the most intelligent fish in the ocean. But little is known about them. Manta rays were first scientifically sighted in 1798. It wasn't until 2009 that researchers discovered there isn't just one species of manta ray. There are two. The giant oceanic manta ray and the slightly smaller reef manta ray. Both species thrive here, in Indonesia's pristine waters. On the edge of the Pacific and Indian Oceans lies an underwater paradise. Raja Ampat, a coral garden packed with mesmerizing marine life, and one of the only places on Earth where both species of manta ray coexist. Raja Ampat is located in the remote eastern corner of the Indonesian archipelago, more than 1,000 miles south of the Philippines. It sits just below the equator, along the southern lip of the Ring of Fire, a belt of raging volcanoes and tectonic plates that rims the Pacific Ocean. The reefs of Raja Ampat are a hotbed of activity. Plunging walls and soaring seamounts encrusted with more than 600 species of coral erupt with life. 75% of the world's coral species thrive here. And more than 1,700 species of reef fish call these corals home. Raja Ampat means four kings in Bahasa, the official language of Indonesia. The name comes from a local myth of a woman who found 7 eggs. From these eggs came 4 kings, who occupied 4 of the archipelago's largest islands, known today as Raja Ampat. Underwater, the reigning kings of Raja Ampat are the manta rays. To preserve the thriving population here, Indonesia established a manta ray sanctuary in 2014, stretching across 2 million square miles of ocean. At nearly twice the size of India, it is the largest manta ray sanctuary on Earth.
Fortunately, there's an awakening which is happening now in Indonesia. It's been led, I think, by manta rays. That's been kind of because of the tourism value of manta rays. And so we've seen really an awakening about the need for conservation.
Dr. Mark Erdman and the team at Conservation International want to protect these charismatic creatures. Mark has logged over 10,000 dives throughout Indonesia and discovered more than 100 new species of reef fish. He now uses his knowledge of these waters to track Indonesia's manta ray population.
From our photo ID database that we have of the manta rays, there's over 400 individuals of the reef manta rays that we've recorded, and something just under 200 individuals of the oceanic manta ray here.
We think this is quite a big population of manta rays that we have here in Raja Ampat. It's a really, really unique place for manta rays and really important that we protect it.
Sarah Lewis has worked with Conservation International and Manta Trust, a UK-based charity that funds manta ray research, since 2010. She and Mark are using a database of photos to help track the populations of mantas here in Raja Ampat and throughout Indonesia.
We have a lot of individuals to ID in this population, which is very exciting.
Raja Ampat's manta ray population could be as high as 3,000. So far, Sarah has identified just 600. The team still has a lot of work ahead of it, and Indonesia's powerful currents don't make it easy. The Indonesian archipelago is bound by 2 great oceans. Strong easterly winds lift the waters of the Pacific 1 foot higher than the neighboring Indian Ocean, pushing water through the islands and creating some of the strongest currents on Earth. For the tenants of the reef, these currents present both rigors and rewards. For those those firmly anchored, such as these soft corals, the flow of water brings a steady stream of food. Others must fight to keep from being swept away. On the reef, shelter comes in all shapes and sizes. Crustaceans tuck into nooks and crannies in the coral. Smaller reef fish sway side to side beneath the canopy, bullied by the current. Larger fish duck behind the plunging walls and seamounts. For researchers, currents are one of the most underestimated and overbearing of all obstacles. Water is 800 times more dense than air, creating strong resistance. Swimming in powerful currents is like walking through a storm-level wind. A current of 2 knots is strong enough to sweep a diver out to sea. Indonesia's currents can reach up to 8 knots, creating a challenge for anyone trying to observe the undersea creatures.
Assuming that the current is moving in a regular fashion and not up or down, most of us divers, we tend to hook in with a reef hook and stay in position.
Reef hooking allows divers to stay put without exerting any energy. Divers use a metal hook attached to a rope to secure themselves to the reef.
And when the current is raging, the sharks and mantis will generally come closer to you. So if you're lucky, they could come by and hover over you in the current.
But reef hooking is not an option for Mark and Sarah. They must be mobile to locate and tag as many manta rays as possible.
We're spreading eyes everywhere, and then we'll all be holding cameras, so we'll be armed and ready wherever there are mantas.
Okay, camera ke Ibu. Okay.
Mark and Sarah leave a remote camera on the reef for an extra pair of eyes. Meanwhile, their colleagues Abam and Abdi patrol a tried-and-true manta site. In the last year, their tracking data has shown that this site is one of the most frequently visited in Raja Ampat. Abam assembles a pole spear so he can get close enough to attach the tracker. But there are no mantas in sight.
We wanted to spread around our tags, giving more numbers out there and see what happens and what we can capture from the behavior of these mantas.
They're hoping that if they tag more mantas, they can learn what draws them to this place and where they come from. But the visibility is poor, and the currents are strong. The best bet is to stay put and wait for the mantas to come to them. Mark and Sarah use a motorized scooter to move from one site to another. They scour the reef, but after several dives, and hours of fighting the current. The team comes up empty-handed.
Studying any wild animal, we have challenges with our research. Even though we have a really abundant population of manta rays here in Rajarampat, sometimes we turn up in the right season, the high season for manta rays, the sites where we know they aggregate regularly, and they're just not there.
But more shocking than what the divers didn't see underwater is what their remote camera did.
What is that? Oh my gosh, that's amazing.
We're a bit dumbfounded, actually. We had mantas about every 5 minutes showing up in the frames. Unfortunately, quite a few of them had just a wing or a head, not a lot of belly shots, but nonetheless, we have definite proof that there were mantas there all the time. And perhaps most exciting, we got a manta birostris, the oceanic manta, which up until this time has never been recorded from northern Raja Ampat. So we're delighted with that. That's a big find, actually.
It's a big find because typically oceanic mantas and reef mantas aren't seen in the same area, let alone on the same reef.
As a general matter, of course, around the world, there's very few places where you get both reef and oceanic mantas together. Raja Ampat is one of those few places where you do see it, but for the most part, they still segregate.
Both species live their lives out in the open ocean, visiting reefs to feed and to be cleaned. Creatures of all shapes and sizes stop in for a tune-up at the ocean's most efficient body shop. Smaller reef fish, like these cleaner wrasse, are specialists at removing parasites and dead skin from larger fish. Butterfly fish specialize in repairing bite wounds. Cleaner shrimp tend to concentrate on the mouth. A manta ray comes in for a cleaning, hovering almost motionless over the reef. A host of cleaner fish greets the long-distance traveler. Gills flared, mouth open, and wings spread wide. The manta ray advertises the areas that need detailing. The T-shaped pattern on its back and fewer black spots on the belly indicate this is an oceanic manta ray. A reef manta ray has far more spots on its underside and a Y-shaped pattern on its back. Despite these differences, for years these two distinct species were thought to be the same, largely because they were so seldom seen side by side, until now.
They have their own separate types of cleaning stations. This is a case where you've got them, both species, using the same cleaning station. That was something we've never seen before. We've only seen reef mantas over the last 15 years of diving on that site. And it really begs the question of how much do we not see when we're down as bubble maker divers.
When the team isn't around to monitor the mantas, a series of acoustic stations listen in on their behalf. These stations sit along the ocean floor and receive pings from any tagged manta ray that comes within a half-mile radius. Every tag transmits a unique signal that's recorded by the receiver. A network of these listening stations tracks how long a manta ray spends at each site and where it travels. The day is coming to an end, but the team still has work to do.
We have here an acoustic receiver which has been in the water since November of 2013. We download it every 6 months or so, and it's time to download it right now. We're basically going to drop in 20 meters of water and hope that we find it.
Mark and his dive partner, Eddie, managed to locate the listening station. It's a simple but effective setup. A rope is chained to a sturdy piece of coral on the ocean floor. The receiver is attached to the rope to detect any tagged mantas that pass by. Buoys keep the top of the rope afloat. Eddie heads up to the boat to download the data, while Mark stays behind to clean barnacles off the listening station. The receiver is sealed with tape to keep it clean and prevent malfunctions. But when a bomb downloads the data, the results surprise him. There's nothing there.
We got nothing on for the last 2 months.
Well, unless there's a malfunction, I would think it's just the batteries have all died out. You gotta put some more tags in.
Yeah, that's all.
After almost 3 years, the tags on the mantas are no longer working. With the old tags now out of commission, the pressure's on tomorrow to tag as many new mantas as possible. As the morning sun pierces through the surface, the underwater world ignites in a kaleidoscope of shapes and colors. Smaller fish swim to the surface to feast on the plankton stirred up by the unruly currents. A tornado of tiny bait fish whips through the water. They came here to eat plankton. A shoal of pygmy devil rays, cousins of the manta ray, pursues the bait fish. It's one of nature's most elegant high-speed chases. The devil ray is one of the deepest, fastest divers in the ocean. It can descend more than a mile. And swim at speeds of up to 13 miles an hour. Nearly 3 times faster than an Olympic gold medalist swimmer. The bait fish defend themselves by joining forces. An army, thousands strong, moves as one large organism. A ploy to confuse the hungry predators. It's hard to pick out a single fish within this silvery mass. several fall out of line, and the devil ray zeroes in on its target. Devil rays are also known for their aerial theatrics. Like acrobats, they launch themselves out of the water, then twist and turn through the air. No one knows for sure why they do this. It may be a courtship or mating ritual. Another theory is that the devil rays breach to rid themselves of parasites that may be shed when the ray smacks back onto the water. Or they may simply be trying to escape a predator. Manta rays are also known as devil rays, thanks to the pair of horn-like fins extending from their mouths. While feeding, the manta's fins unroll to direct plankton into its mouth. After dinner, the fins neatly roll back up once again. Manta rays are filter feeders. Most often, they are seen feeding on the surface, where plankton is abundant. Their mouths are wide enough for an adult human to fit inside. But the manta's throat is no larger than a human fist, restricting its diet to tiny plankton. When there's no plankton floating on the surface, manta rays seek it out in other ways. These manta rays twirl through the water column, performing barrel rolls for hours. This graceful underwater ballet is actually a sophisticated foraging technique designed to clear a densely concentrated patch of plankton. Both the surface and midwater feeding methods require specialized filaments called gill rakers that filter food. Plankton-filled water enters the manta's throat and is pushed through the gill rakers. The water comes out through gill slits on its belly, while the plankton is trapped inside. Fisheries target mantas for these gills. Rakers are used in Chinese medicine and are thought to cure everything from cancer to the common cold, though there is no scientific proof. Manta rays are listed as vulnerable to extinction due to reckless overfishing. For decades, Indonesia has been one of the world's largest exporters of shark and ray parts. So the study at Raja Ampat is key to manta conservation. If they can understand where Indonesia's manta rays spend most of their time, they can better decide which parts of the huge ocean territory to monitor. Patrol boats are assigned to frequently visited manta sites to ensure illegal fishing boats stay away. But if they don't know where the manta rays are, they can't protect them. The discovery last night that the batteries on the old tags are beginning to die means Sarah and Mark urgently need to tag new mantas to continue the study.
We work together with all of this research, and specifically with the tagging, it's really important that we have at least two of us to do this tagging process, because it's important that we get the photo ID of the manta before we tag it.
They'll use the photos to keep track of which mantas they tag, if they manage to tag any at all. The water is clouded with plankton, which increases the chance that there will be mantas on the reef. but decreases Mark and Sarah's ability to see them. Visibility is less than 30 feet. Even if the mantas are here, Mark and Sarah might not see them. Through the cloud, Sarah spots a moving shape.
Every single individual manta ray has a unique pattern of spots on their underside, and these act kind of like a human fingerprint, so we can use these spot patterns to actually identify individual mantas.
She positions herself beneath its belly for the perfect shot.
And we just aim to try and photograph the bellies, the spot patterns. And during this process, we're also observing things like pregnancies, we're observing the sex of the manta, so whether it's male or female, whether it has any injuries or mating scars, and what sort of behavior it's doing.
This is a male reef manta ray. Mark approaches cautiously, careful not to spook him. Tagging requires focus and precision. He has to aim the pole spear at a small area in the crease of the wing, where it won't hurt the manta or limit its mobility. Success. With one manta tagged, the team soon spots a second chance. Sarah tucks beneath to get a photo ID. Mark waits for his signal, then edges forward. Another tag is in.
These tags give us very different sort of insights into the manta rays' habitat use and movement patterns. We're getting a much better idea of how they're actually moving between specific sites and how long they're actually using these sites, how important they are for them.
The quick jab feels like being poked with a vaccination needle, but a little discomfort now will save this species later.
So this is really important data for us, and it also means that we are better understanding which sites are most critical for further protection and further conservation efforts.
After a successful day, Sarah is eager to upload her photos.
Every time we get a new photo, we can then compare that with our database of already identified individuals to see if it's a new one or if it's one that we've already cited before. We actually recorded 8 new individual mantas, which is fantastic and adds to our database. And over time, we can actually make estimates of population size. So if we continually identifying individuals from population, once we reach a stage where we're getting mostly recited mantas, we can then start to make an estimate of how big that population is. So far, altogether in Rajarampat, we have almost 400 individuals identified.
With an estimated population of nearly 3,000 mantas, there is still a lot of work to be done. As night sets in, the team sets out. Wayag Island. More than 350,000 acres of lush atolls and vibrant corals. Limestone islands rise from the water like mushrooms sprouting in the sea. Green jungle blankets the islands. Pristine beaches skirt the coast. The crystal clear waters of Wayag offer a window into an underwater world that is equally enchanting. Wayag Lagoon is the first manta ray nursery discovered in Southeast Asia, a place with the potential to answer 2 of the most important questions about manta rays: where and how they give birth. Manta rays are ovoviviparous. They produce eggs that hatch within their body, so the young are born alive. But a manta birth has never been documented in the wild. It is assumed that a healthy mother gives birth to just one pup every 2 to 5 years throughout her lifetime, which is thought to be 40 years. Most females don't reach sexual maturity until they are 10 years old. Pups can weigh up to 25 pounds and grow to 5 feet in length. The pup's fins stay curled up while they're inside the mother. Once born, the fins stretch out and the pup intuitively starts to swim. Mark and his team discovered YAG's nursery just 1 year ago after successfully tagging juvenile manta rays in these waters. But many questions remain unanswered. Mark isn't sure whether females are giving birth in the lagoon or whether the juveniles have somehow found their way here. He wants to tag more juveniles or a pregnant manta ray to find out. It's rising tide, and the team suspects manta rays will be feeding on the surface. For the first time, they will use a drone to survey the area more efficiently.
Normally, we do this boat base, so we basically have polarized glasses on and we're just cruising around the lagoon, and it's a bit hit or miss as to whether or not you can see through the water. Occasionally, we've been lucky enough to have a helicopter, but for the most part, we do it by boat base. But this is fantastic. So we've got the drone hovering right over the cleaning station that we found, and just hoping that we're going to see one of the baby mantas come swimming along right there.
Really? It does. Oh my gosh, it really does.
So we're not 100% sure, but we have what looks like a manta right up on the surface. It's got a lot of glare, so it's quite difficult with the overhead sun, but it looks like a manta, so I think we're going to run over there and check it out.
Here we've got a little baby juvenile reef manta ray, and we just discovered this morning that this site right here is actually a cleaning station, and we've seen him now a couple of times cleaning right here. So we're going to get Ronald in to try and get an acoustic tag in this little baby.
Ronald is a local diver. He's worked with Conservation International for the past decade and has been diving here even longer.
What we found with these babies in this lagoon is that for the most part, most of them are quite skittish, a little bit scared of people, but they also tend to be a little bit curious at the same time.
Ronald slowly approaches the juvenile manta, but his presence isn't well received.
It was in curious mode, but it very quickly switched to skittish mode and shot away.
Sometimes we come across individuals that just want nothing to do with us, really skittish and no chance.
It's unfortunate, that's just kind of the game here with the little ones. So.
With the juveniles slipping away and no pregnant manta rays in sight, this time the team must leave YAG's nursery with their questions unanswered. But over the next few days, the team identifies 7 more new individuals, adding to their growing database of 600. It's a great start, but there's still a long way to go.
We reckon that there's probably at least 2 or 3 times that amount in the total population.
Mark uses the last few dives on this mission to collect genetic samples. He wants to know if manta rays in Raja Ampat are mating with the populations from surrounding islands. Mark uses the probe attached to his tagging pole to collect a tissue sample. and stows it away in a vial for safekeeping until he's back on dry land. These genetic samples will reveal whether the mantas at Raja Ampat have been breeding with more distant populations in the last 3 to 5 generations. Knowing whether there is a genetic connection is critical to their conservation. If there is none, it would mean that one population can't replenish the other. And these manta rays will require far more protection than previously thought. Genetics also provide clues about how these gentle giants evolved. Sharks have been swimming in our oceans for more than 400 million years. Scientists believe rays originated from sharks more than 150 million years ago. They evolved to adapt to life on the seafloor. Primitive rays are thought to resemble the present-day stingray. They swam using wave-like motions and were armed with a stinger on the tail for defense. Modern stingrays have a spine in their tail, serrated with sharp edges. Many species also have venom, which they deliver through their tail. Manta rays, as we know them today, appeared about 5 million years ago. A subtle bump on the tail of the oceanic manta serves as a reminder of a time in evolution when the mantas lost their sting. Both manta ray species can be either one of 2 color patterns, called color morphs. One is all black. The other, called a chevron, has a white underside and black back. Black morph manta rays have a recessive gene and typically make up only 25% of the total population. In the Maldives, generally considered to be a mecca for manta ray sightings, no black manta ray has been identified in its estimated population of 5,000. Sarah and Mark have spotted 10 on this dive alone. Back on the boat, Sarah's newly identified manta rays support a theory that has implications for all mantas.
We've added some new individuals to our database, quite a few black morph mantas, and this pie chart here is showing the color morph ratio. So we've got 63% chevron mantas and 37% black mantas. Why do we here in Raja Ampat have such a high number of black color morph manta rays? One of the theories is that this area, this region of the world, is perhaps the center of evolution for manta rays, and that as the populations, the mantas spread globally through time, that black morph, it just got phased out. But still here in the heart, perhaps, of where manta rays evolved from, we still have that relatively high proportion of black manta rays.
Could Raja Ampat be the birthplace of the black morph manta ray? Or is this black manta population growth actually a cause for concern? Chevron mantas have what's called countershading. Whether looking down against the inky black ocean bottom or up against the white sky, the chevron manta stays well camouflaged to evade predators. From below, the dark belly of the black manta ray stands out against the light sky, making it an easy target for sharks, the natural predators of manta rays. But if they are more vulnerable to predators, why are Indonesia's black manta rays thriving?
The last 30 plus years, Indonesia has been the world's largest shark and ray fishery. They've been exporting more fins and more bits and body parts of sharks and rays than any other country on the planet by far. That's had an impact, a serious toll on the populations here, to the point where it's quite difficult to go anywhere in Indonesia and see large sharks anymore. They're pretty much gone.
It is possible that the black manta ray population is thriving because the low population of sharks means there are no predators to eat them. Indonesia's waters are now a protected marine area, declared a no-fish zone for both sharks and manta rays.
We're getting there. It's a slow process, and to be sure, there's been a major impact. I've been watching their populations recover and rebound, which is something which is really reason for hope, I would say.
The manta ray is so fascinating for me in their gentle way of moving, and they're actually really graceful animals.
They're making progress, but Mark and his team know there's still a long road ahead.
It's a really, really unique place for manta rays, and really important that we protect it.
From the fight to save these beautiful rays, to the discovery of groundbreaking revelations about their secret lives, every dive at Raja Ampat is a chance to learn more about the gentle giants of Indonesia's untamed seas.